The last statistics that we're going to look at is sort of the big kahuna, and it's called regression. It has lots of things that it has to, rules and regs, so to speak, and it usually has to have continuous data. You can use some dummy variables, but you'd have to take like a nominal variable or an ordinal variable and then sort of collapse it down into a yes, no, either a 0 or a 1. And that's called a dummy variable, but you'd have to transform the variables into that, and it can't take too many of those. So it's sort of got much more confined rules that you have to sort of follow, and from that logistical regression also, which we'll talk about at the end of the video. But what regression does is it sort of looks at where the dots are, and then it imposes a line. So if all your subjects sort of in your, and this is one of the reasons why we do those plots of where everyone goes, or we look at sort of change over time, and we can do like a model and look at that and look at where the variables are. And if we see that they're all like right here, then the line is going to be imposed much further up. This is again why we look at mean and mode, and we look at like outliers, right? Because that does impact regression. It can impact whether or not the relationship is true or not, and it's one of the rules that you have to look at, and the constraints. So we can do regression, but we sort of have to know a whole lot more about the data and the limitations of the data before we can do a regression model. And you have to have certain kinds of data. Again, this is why we talked about this in the very beginning. You have to have certain kinds of data. It's mainly continuous data, but you can build a very robust model, which is really nice. So you can add in everything in the kitchen sink. There's a problem with that, though, because eventually everything looks like it's significant, and it's not. But this is a much more complex, bigger model, like based on the ANOVA, it's even bigger. One of the things that it has to have is you have to have not too many outliers in regression. These are sort of the rules of the road. Again, because it can pose, if all my group stuff is over here, my line's going to be imposed further up. If all my stuff's further down here, my line is down this way. It's assuming that if on this, that whenever this goes up, this goes up, this goes up, this goes up, right? And that line, my hand is the line, wherever that line is imposed is where those points are in your data, okay? Usually with regression, you can put out a scatter plot too, so you can actually see what's happening. Sometimes the visual helps. There'll be another video about that, trust me. But you also need to make sure that stuff isn't correlated. So one of the reasons that I bring that up is sometimes when we do income and education, they're very highly correlated. The more education you have, the more money you make, right? So they go up together. And it has no impact about your independent variable. One pushes the other, so you have to make sure that that's not there. And one of the nice parts about a regression model is if you see that you have education income happening, you can take one of those things out and run the model again and see what happens. Again, those are continuous variables, and you can sort of see if certain parts of your outcome come out more significant or not. The best part about regression is you can add stuff and take stuff out and see what happens to your significance level. And you can sort of see if you have some of these issues once you play around with the model. But it's very much a model, and it has lots of moving parts. Another thing is we're assuming that this relationship, when this goes up, this goes up, this goes up, this goes up. We're not assuming that it's like this and it curves, so it can't be curvilinear. And again, that's one of the issues when you see and why you plot it, just to see what's happening there. Also, you can't have like lots of people here and lots of people here, because then it means it's spread out. Heterodiscicity, it's a very fun word. It means there's a problem of unequal variance. A lot of this has to do with unequal variance, but there are different ways of looking at it and understanding it. So instead of like outliers here and here, which means there's not going to be a lot of variance, this is sort of looking at when they're scattered all over the place. Autocorrelation, sometimes that happens over time. So like the more someone stays in a program, or the more, if they've come to 6 sessions versus 2, then they're probably going to have a higher test score, right? And that's really sort of, autocorrelation is a problem of that they're related over time. So they may not be correlated in the beginning, but as you add stuff, they would become related over time. So like the more education you have, the better you might do over time. The more sessions you come to, the better you do over time. Those kinds of things. So you would look for that at specific time points in this model. So you have to make sure that those things are controlled, and it's really hard to do that. But again, you putting all these things in a model, you can tell. And one of the ways that you can tell with specifically with regression is that you produce something called an R-square. And what the R-square is telling you is what percentage of the variation in your model is explained by those variables that you've picked. You'd love to have 0.08 because that would mean that like 80% of the variation is explained by what you pick. So the closer you have to 60 and above, the better off. But again, one of the things you can do is take out specific things in that model and rerun it to see what's impacting what, to see if there's too much autocorrelation or if correlation happens later. See if there's multi-correlation, so if those variables correlate with each other, take one out. Autocorrelation, you could take it at different time frames. So instead of time 1 and time 2, you could see if the people who came just to certain sessions, whether they did have a significant outcome with the intervention, or if people who were high coming up to everything had lots of intervention and lots of sessions, did they change? Again, you can take out and add different parts. You just have to transform your data a little bit, and then you get that R-squared that sort of tells you. Sometimes taking everything out doesn't matter, so then you can say there's less of a chance that you have these in your model, but you kind of have to rerun this a whole lot. And that can get really interesting. And one of the things that we're looking at, but it's very much looking at independent and dependent, and what that independent does to all those dependent variables. Again, it's a model, so you can add lots of dependent variables. You can add things like race and gender and all kinds of things like that, and see what happens over time. So it has a lot more of a story it can tell, but again, you have to have some continuous variables. And if you don't have that, that's very difficult to use this, and you're automatically going to have those issues. If you don't have a lot of variance, then it's a limitation of what you can use. And then we would sort of go backwards to like a paired t-test or to an ANOVA, those kinds of things. So again, the type of data you have, what kind of problems are there in the data, because you get the data you get, determine what test you can do and how reliable the results are from that test. So again, that's why we start with always knowing what's in our data, and then we move upwards. One of the things, though, that people do is a lot of times we have logistical regression, which is a type of regression, but it's predicting that one dichotomous dependent variable will impact the independent variable. So if you have a lot of, not necessarily dummy variables, but if you have a lot of nominal variables, gender, race, things like that, this model's better because it's saying if this, then this, and it's not considering everything a continuous variable with a few dummy variables poked in. It's assuming that you've got more nominal, more categorical variables. Why it's sort of different is that it's looking at different outcomes, and the R-squared is still important, but it's a little bit less robust in the sense of you can't add everything in the kitchen sink because very soon things go away and nothing is significant, or everything is significant and it's not really telling you anything. It's not allowing you to predict. One of the nice parts about regression is it's sort of helping you to predict, if I do this, then this will happen. And you can predict over time. It's a little bit harder to do that with the other variables, in part because you can't make as robust a model. One of the great things about logistical regression is that you can, managers use this a lot, policy evaluators use this a lot, because we're trying to look at collecting data over time, and it sort of has an implied time series impact to it. And we can also look at if autocorrelation happens over time. Remember we talked about that, and regression is one of the things you can't have. This is sort of telling us, do you have autocorrelation over time, and you would collect it over different time periods. Again, if you looked at an intervention and you had people who were high attenders and came to all the sessions and suddenly their scores were 100% versus people who came to 1 or 2. You'd reconfigure the data, rerun it in a regression or logistical regression model to see what the outcomes are. Again, it depends on the type of data you have and how much variation you have. These are really great models because you can use them to predict. You can also use them to see if time has an impact. You can also see what kind of impact it might have in the future if you redo the program. Where it has the most impact. Is it at 2 sessions? Is it at 100% attendance to every session? Is it got the most impacts for this individual, not these individuals? So it sort of helps parcel those out, but again, it needs a lot of continuous variables, and you may not have that. Hence, you would use logistical regression. But again, there's still some constraints on this. You get the data you get, and if it doesn't have a lot of variation, then you may not get significance, and you may have to go back and do a different type of test just to see what happens. Again, there's no You know, it's sort of like, and I will give you a decision tree, that's what we call it, and it will look at independent and dependent variables, and it will look at the type of variables, and then it sort of tells you which kind of tests you can do as sort of a guide. One of the reasons I'm not going to teach you every test under the sun, just like the same reason in medicine we don't run every test in the world, is because certain tests tell you whether or not you should run other tests. Okay, but you have to the outcomes of those initial tests, and that's very much like statistics. So I'm sort of teaching you the basics, and then we look at what your data says and what your R-squared are if you get to regression, or what your other things say based on the output, and then we can sort of determine, is there a relationship, how does it happen, where does it happen, if it happens at all, and then we can answer our hypothesis of if this, then that. If we do this with a policy intervention, we'll get this. If we do this kind of educational intervention, we'll get this. If we do this kind of programming, we'll get this. If the time from getting to one place to another is such and such at a certain institution and we reduce that, we'll get this. So again, all of these things tell you a different story about your data, but your data very much controls what kind of tests you can do. And if you don't have a lot of variance in your data, then you have to do different kinds of tests. But we get to that when we get to that. These are sort of the standard tests, and that you can use them for a wider range of things. But one of the things you really need to do is you do a test, but you don't say that this is the end-all be-all, and you understand the constraints and limitations of the test.